Hello and good afternoon. Ladies and gentlemen, I welcome you all to Tasking's webinar on the VX toolset for ARM version 6.0 R1P1. We are now supporting the NXP S32K3 family of microcontrollers, and this will be the content of the webinar. My name is Bharat Koppa. I am a technical sales engineer at Tasking, and I will be the moderator of today's webinar. In the next 15 minutes, our technical marketing manager, Roger Smith, will guide you through the main tools and the main tools and features of the Tasking VX toolset for ARM. He will also give you an overview of the NXP S32K3 family of microcontrollers, and he will also provide details on the new TÜV Nord certification for the VX toolset for ARM. Tasking is active partners with leading OEMs and tier ones, and we focus on safety critical and cyber secure software development on multi-core architectures. Tasking provides a complete development environment that allows software engineers to develop reliable, functionally safe, cyber secure, and high performance applications. Tasking provides tools that can be used in different stages of software development. The Infineon Oryx Tricore toolchains are ASPICE Level 2 compliant and conform to the ISO 21434 cybersecurity standard and are TÜV certified according to ISO 26262 up to ASIL-D. We have been successful in receiving a TÜV certificate for our VX toolset for ARM as well, and the certificate can now be downloaded from our website, and this will be explained in detail in the next minutes. The Tasking performance tools, Embedded Profiler and Multi-Core Performance Tool help detect cross-core memory accesses and provide guidance on how to reach an equally distributed core load in your multi-core system. The Tasking safety and the security ecosystem includes the Safety Checker static analysis tool that can help ensure freedom from interference in ECUs with software components having different ASIL levels. The Tricore Inspector provides embedded system developers an automated method for identifying if the SIL 2, 3, or 4 toolset related issues are present in the compiled output code. Finally, Tasking offers qualified C and MAT libraries as per ISO 26262. And for the hardware configuration and Oryx port mapping for your PCB development, the Tasking pin mapper completes the portfolio. Some information about today's webinar. This webinar is being recorded and will be available on our website at the link shown below in the next couple of days. And we also invite you to review our previous webinars, as well as our library of application notes, white papers, and the tips and tricks videos. In case any questions arise during the webinar, we invite you to use the Q&A function on the Zoom console, and all your questions will be answered at the completion of the webinar. A short introduction on our today's speaker. Roger Smith is a technical marketing manager at Tasking. He's an electrical engineer with over 25 years of experience in designing, implementing, and debugging automotive electronics. In his previous role, he has spent 12 years as an application engineer supporting braking, EPS, and passive safety applications for a global automotive semiconductor leader. And Roger is a technical marketing engineer since 3 years at Tasking, and he's supporting customers in the US with wide range of multi-core embedded software development tools. With this, I would like to hand over to Roger.
Thank you, Bharath, for the kind introduction. I'd like to welcome everyone to today's webinar, where we will be focusing on the added support for the NXP family of S32K3 microcontrollers. As this following diagram here shows, we see some very typical body controller applications. What we are seeing when we look out into the market is that certain safety requirements are beginning to creep their way into these convenience features and functions. So, for example, here in the seat comfort area, we see with a common seat heater function that ASIL-A is starting to creep into these requirements, as if the protected MOSFET either fails with its short circuit protection or goes into an overload condition, you can actually cause some physical harm to the driver. And so in this instance, microcontrollers are still going to be the basics of any automotive embedded application. So with body controller applications, we're also seeing that specific microcontroller requirements are coming into a play. For example, quiescent current is very important. In a common luxury vehicle application, as you're approaching your vehicle on a hot day, you can take your fob and you can actually open up the window so that before you get to the vehicle, some of that hot air is released from inside of the vehicle cockpit. For these types of applications to work, the ECUs must wake up periodically and look for a control signal. And so if we don't have, if the microcontrollers don't have a low quiescent current rating, what can happen is if you say go away on a trip for a while and you park your car at the airport, what you don't want to have happen is your battery to be dead when you get back. And so it is very, important that we be able to support these different microcontrollers. Looking at other trends, available right now in the market, OEMs are beginning to combine features and functions, and they're doing this so that they can improve packing density. They can reduce harnessing, which in turn reduces weight, increases fuel economy, lowers your CO2 emissions, improves EMC, and in the end saves money. However, there is a consequence of combining these complex functionalities, and that is that the single core microcontroller is no longer finding, significant roles in the automotive electronic space. And so we're starting to see more and more multi-core architectures with various switch inputs, safety, cybersecurity requirements, as well as high performance requirements. So these safety and cybersecurity requirements, which are specified by ISO 26262 and ISO 21434, can add additional code and complexity to your system, which thereby increases your code size and reduces your performance. So it's ultra important that we choose the right compiler for such safety and cybersecurity applications. And I think it goes without saying that the ECU developer, they're in business to make money. And so if they can use a more cost-effective microcontroller, and have very efficient code, which they can fit into a smaller memory footprint, then their overall business case is more appealing. And so we're seeing many OEMs and tier ones are taking advantage of the tasking Viper technology to significantly reduce code size, but still meet their real-time requirements. So if we take a quick little snapshot here of the S32K3 family, you can see it's a general purpose microcontroller, which has a footprint in many different applications. So you see where it's currently being utilized within the powertrain and chassis, infotainment, ADAS, and body and comfort application areas within the vehicle. And if we focus here on the K3 particular family, you can see that we have multiple levels of ASIL here, which can be supported. These devices help to enable software reuse across multiple applications, and they also help to reduce the complexity of the vehicle software development. Some additional safety features, added higher operating frequencies, and more memory is also allowing this particular device to expand into new applications like advanced body electronics, battery management, and zone control. And we're also seeing a renewed focus on environmental robustness. So if we take a look here at the tasking VX toolset for ARM, this webinar is going to focus on the newly released patch 1, which does add, support for this NXP family of microcontrollers. This version of the toolset is based on Tasking's proprietary Viper technology. It comes with a C and C++ compiler and is still based on the 64-bit Eclipse IDE. The toolset will provide the same user experience as the well-known VX toolset for Tricore. The toolset will support the libraries defined by the ARM application binary interface. The toolset comes with an ARM instruction set simulator, which can be used for single core debugging. And it will also supports the integrated multi-core debugger, and is currently uses the Sager J-Link probe to interface the IDE with your target hardware. Some additional features here which are supported are kernel support modules with RTOS aware debugging are supported. And so they generate the ORTI or the OSEC runtime interface, and which allows you to enable or allows your debugger to become OS aware. And finally, as Barath already mentioned, is the tool set is TÜV certified, so it is suitable for developing automotive applications up to ASIL D and industrial applications up to SIL 3. So some of the advanced features of the tool set is we have a highly configurable linker and versatile script language for optimal memory control. This allows the user to specify characteristics of their specific target board. And it also allows you to specify how sections of code are located in memory. I do invite you to go up on our website and look at the introduction to LSL and strategies for reducing your link and locate time. There's a really a lot of good information there on the versatile script language that we provide with our tool set. In addition, we have integrated MISRA-C and CERT-C code checking, and there's runtime error checking, which is also built in, which addresses topics such as division by zero, bound checking, stack overflow, and malloc consistency checks. The processor abstraction layer, or CMIS, grants users access to the source and header files for every peripheral on the device. And finally, you can also support, or you can export the S32DS application projects to tasking. There is some minor manual configuration which is required. However, these projects can really simplify, your development on the NXP S32K3 device. If we take a quick view here of the actual architecture, what we can see is that there are multiple memory options, including P-flash, D-flash, RAM, tightly coupled memory, and extended memory. So the extended memory is supported via the QSPI interface. What we also see is that the family offers a scalable ARM M7 architecture, and we'll see that in more detail on the next slide. And there are also variants which are lockstep, and so they do support up to ASIL D. There are numerous safety features that are added to this particular family of microcontrollers. Hardware redundancy, built-in self-test, monitors, and the device is ASIL D compliant. Hardware accelerators are available for your cybersecurity requirements. And there are many different communication interfaces supported with Ethernet, CAN, CAN-FD, and LIN. If we look at a table of the different features, you can see the different variants which are currently supported. As I previously mentioned, you see we have multiple devices here which have a single Cortex M7. We have the dual Cortex M7, and then we have the single Cortex with a lockstep. You can see that in terms of safety levels here, we have ASIL B and ASIL D supported. You can see that we have a scalable flash and RAM. The family offers scalable flash and RAM. And we offer for cybersecurity the HSE under B setting, and this is done via the independent security subsystem with the NXP firmware. This does support firmware over-the-air updates, and ISO 26262 compliant real-time drivers are available for both AUTOSAR and non-AUTOSAR applications. In terms of driver support, there's a wide range of standard low-level drivers and complex device drivers, which create a rich ecosystem, which is integrated into a unified development environment. And you can also see here that each driver does provide 2 sets of APIs, one compliant with AUTOSAR and the other is for non-AUTOSAR applications where any interface can be used based on the scope of your application. So moving on to the actual tool set, you can see here screen captures from the release tool set. You can see here the S32K variant members that are currently supported when you're creating a project. Here from our standard C++ perspective, you can see again that the look and feel is exact to our VX tool set for Tricor. You have your workspace, you have the opportunity to look at your source files, you have your search windows, very, very similar or the same. So again, if you are familiar with our Tricor tool set, there will be no learning curve for moving on to the ARM tool set. I'm showing here a screen capture from our debugger perspective, which is using the ARM-based simulator. So you can see here that we're using the ARM simulator. You can see here that the simulator registers are loaded. We have a common disassembly view, and you can also see that the variables, breakpoints, and expressions windows are very much are similar to what you're used to if you're familiar with our Tricor toolset. And you can see here also the debug perspective, which is being used here on the NXP development board, and this is being used with the Sager J-Link. So if we look at the 30,000-foot view of the overall process, you can see here the NXP S32K3 development board. You can see the J-Link probe here, debug probe that sits between our tool set and the hardware. And you can also, we've provided a link here for you to go and look at the different options of Sager's J-Link probe, which is available to, which acts similarly to the Infineon Mini Wiggler when you're looking at the Tricor toolset. So as Barath did mention, this tool set is certified, TÜV Nord certified for up to ASIL D applications. A key distinguisher here is there's many different members of the ARM family. Tasking in the VX toolset for ARM will focus on safety applications. And so again, we are suitable for automotive and industrial application development up to ASIL D and up to SIL 3. The safety manual is now included with your product license, and you can see here that the safety manual is included with the other compiler product documentation. So there's no longer a need to purchase an additional compiler qualification kit. I have showed here just a screen capture from the safety manual, and you can see here that based on your different your compiler options, there's you have options that have an impact on safety, where we provide the positive recommendation, which basically says, you know, you're to use this particular compiler optimization setting in a safety application. And in many times, your safety case will require you to provide an argument if you don't use that option. You can see here that in the screen capture that I've provided is that you can see the options which have a neutral recommendation or they have no impact on safety. And then you can see also here the negative recommendation, which means that, you know, these options also have an impact on safety and they're not to be used. Barath mentioned it briefly earlier, but currently only the VX toolset for Tricor 6.3R1 and Smart Code are cybersecure ISO 21434 compliant. The intent is for this tool set to be qualified, and it is currently in the certification process. So if we look at the different licenses that are available. This product there's a time-based and a continuous integration license available. You can see node locked and floating licenses are available. There are evaluation licenses, again, which we encourage you to reach out to our team, and you can get some experience using the tool set. So some of the key takeaways from today's webinar is, software applications up to ASIL D can be developed. The tool set is already TÜV certified. The same user experience will be provided as the well-known Tri-Core tool set. The ARM tool set has been tested for ISO C11 and ISO C++14 conformity using industry accepted validation suites like Perennial and Plum Hill. We support, the new multi-core product offerings from NXP. Advanced debugger features with the ARM instruction set simulator are included, with the tool set. The debugger has special support for debugging real-time operating systems, or otherwise known as, RTOS-aware debugging. And also we support the microcontroller abstraction layer with support for the intrinsic register and instruction accesses. So with that, I will hand back over to Barath for a wrap-up.
Thank you very much, Roger, for this nice presentation. And I also thank audience for your attention. We are official software and tool partners now with NXP, and we are also aligned with NXP by intent and strategy. Below links leads you to the NXP website, and you can see that tasking is listed, and also the VX toolset for ARM is listed on the website. And if you need any more information, please contact our technical marketing director on the email shown here. Some more interesting news for you: tasking and iSystems will join hands and will focus on providing intelligent solution for customer needs. Initial agreements have been formed, and we are going through the regulatory process, which still needs to be cleared. And with this merger, tasking intends to be your one-stop shop for embedded software development. Also, please, you can follow us on LinkedIn, and please have a look at the event sections event section on our website for more upcoming and interesting webinars and events. If you have any question related to any of the products that were mentioned in the product portfolio, or if you would like to evaluate any of the product, please write us an email at sales@tasking.com, and one of our sales representative will get back to you. Now let's move on to the Q&A. I see that there are a few questions already from the audience. Okay, so the first question, Roger, do you need to purchase the safety manual separately for each ARM device?
No, you no longer need to do that. And so if you look back to our VX toolset for Tri-Core, there was a qualification kit option that was offered. However, moving forward with this ARM toolset, the safety manual is included, and there's no additional need to purchase a qualification kit. Sorry.
Mm-hmm. Okay, so next question. How many updates are foreseen each year for the compiler?
So that's always a hard question to answer. A lot of it is based on industry feedback and with issues that are seen out in the actual development arena. At this point, we're anticipating a couple updates a year, but that of course could change.
Mm-hmm. So if you have any further questions, please do write to us. Use the Q&A option on Zoom. One more question. Are there any roadmaps available?
So the roadmaps are currently internal to tasking. And so if you're inquiring about a particular update version or when a new release is made, I I would ask you to reach out to your local field application engineer support, or you can contact Florian Susmeyer, whose contact information was on one of the slides.
Okay, thank you. So moving on to the next question, we are using iSystems debugger for debugging code on Infineon Oryx. Is this also compatible with the ARM compiler?
So you can, so WinIDEA or Lauterbach, PLS, any of the other major debuggers, you know, can work obviously with our tool set. The part that you need is the hardware interface that sits between the development environment and the microcontroller. And so with our particular tool set, you know, you will need to use the Sager J-Link probe as highlighted within the slides. For using other third-party debuggers, you know, they have their own JTAG, DAP interface connectors to connect to their hardware unit to the module.
Mm-hmm. So there's one more question from the audience. Will this new ARM compiler work for any Cortex-M?
So there will be a the answer is yes. You know, with the LSL language and you can fine tune, you know, the interface file to work, you know, with the tool set and your end hardware. Only the safety relevant architectures, primarily from Infineon and NXP, will be kind of included automatically, say, within the tool set. So you can always go and you can use the, you know, you can fine tune your configuration files, which require more manual effort. But, you know, in terms of just going and automatically finding, you know, the files, et cetera, to support a microcontroller, we'll be focusing on the safety architectures. But yes, the ARM Cortex-M7 is one of those targeted architectures.
Mm-hmm. Thank you. So if there are any more questions, so you can write to us. So I think there are no further questions. So we could end this session. So thank you very much for your participation and patience. And as already mentioned, if you would like to evaluate the ARM compiler, so please write to us and our sales representative will contact you, will get back to you. So with this, we wish you a very good afternoon and thank you very much. And until the next webinar.
Thank you. Bye.
Bye.